Hello students, in this video we will discuss about conductors, insulators, properties of conductor and electrostatic shielding. First point is conductor. What is conductor? Conductor is a substance that is allowed to pass the charge inside it. And insulator, what is insulator? Insulator is a substance that does not allow any charge to flow inside the conductor, inside the insulator. Means if there is a conductor, that means any charge can flow inside the conductor. If the substance allow the charge to flow inside, it is a conductor. If it is not, then the substance is insulator. Means electrical conductor in electrical insulator. We can say that, in other words, if any substance gives the path to flow a charge inside it, if it is providing path to flow inside the substance, that this is a conductor. If it is not, then the substance is insulator. In next, electrostatic properties of a conductor. Very important topics. Many times it is asked in the CBSE board. These are the points. This is the properties of the electrostatic properties of a conductor. कंडक्टर्स की क्या क्या प्रॉपर्टीज होती हैं, इन 6 प्रॉपर्टीज को हम लोग वन बाय वन डिस्कस करते हैं. पहली प्रॉपर्टी, नेट इलेक्ट्रिक फील्ड इज जीरो इनसाइड अ कंडक्टर. नेट इलेक्ट्रिक फील्ड इज जीरो इनसाइड अ कंडक्टर मीन्स if any conductor is placed inside an external field is toward the side, that means there may be a positive plate and there may be a negative plate, because the electric field is from positive plate to negative plate. This electric field is an external electric field. Conductor, the behavior of the conductor in an external field will be this conductor will have many positive and negative charges. If there is no external field, the positive and negative charges will be distributed uniformly all over the conductor. If there is an external field, if the conductor is placed in an external field, there will be a movement of the charges. That means the electron inside the conductor, means free electron inside the conductor, will tend to move toward the positive plate. That means this conductor will have negative charge toward the positive external plate, and opposite same positive charge here toward the negative plate. That means there is a induced charge by the external electric field. There will be an internal electric field, or we can say that the induced electric field in this side inside the conductor. Due to the induced charge, there will be an electric field from positive to negative plate, from positive to negative charge, means there will be an induced electric field in this direction. Electric field is in this direction, external electric field is in this direction, and induced electric field is in this direction. At the equilibrium, external field is equals to induced field. That means net electric field external minus induced, that will be 0, because external electric field and induced electric field is 0. That means the net electric field inside a conductor when the conductor is placed and when the conductor is placed inside an external field, the net electric field inside the conductor is 0. This that was the first point. Net electric field is 0 inside a conductor. Next point, electric field is normal to the surface of a conductor. Normal to the surface of a conductor means electric field is always normal. We have studied in the previous chapter that electric field is always normal to the surface of the conductor. Why? What is the reason? What is the reason behind this point? Electric field is normal to the surface. Electric field is normal to the surface. Let us suppose there is a conductor. This is the conductor. We suppose that the electric field is not normal. Suppose that the electric field is not normal. The electric field is tangential, means making some angle with the surface. Means there will be a component along the surface, electric field cos theta, and a perpendicular component E sin theta. If there exists a electric field along the surface, that means the charge inside the conductor, or negative charge or positive charge inside the conductor will move along the electric field component. That means there must be a current, because the charge is flowing, there will be a current. There must be a current on the surface because there exists a horizontal component or component of electric field along the conductor. There must exist, but in practical there is no electric field along the surface. There is no electrical current along the surface. That means the component of electric field along the surface is 0. That means this part is 0. E cos theta equals to 0. There is no current along the surface in practical. That means horizontal component is 0. If there will be a current in practical, that means the horizontal component is not 0, because any charge in an external field is moving. If this is positive, this is moving along the electric field. There is no practical current. On the near the surface. That means the component along the surface is 0. That means E cos 0. That means cos theta is 0, where theta is equals to 90 degree. That means the electric field is always 90 degree, making 90 degree angle with the surface. Or finally we can say that electric field is always normal to the surface of a conductor. Next point, is net charge inside a conductor is 0. Net charge inside a conductor is 0. We all know that flux is equals to Q by epsilon naught, and flux is equals to E dot S, or E into S cos theta. Net electric field is 0 inside a conductor. We all know inside a conductor, net charge inside a conductor is 0. Because electric field is 0, E dot S is equals to Q by epsilon naught. We all know that Q is equals to epsilon naught times E into S. If electric field is 0, as we have discussed in point number 1, net electric field is 0 inside a conductor, Q is equals to epsilon naught 0 into S, that means 0. We can say that net charge inside a conductor is 0. Net charge inside a conductor is 0. Next point is potential is constant inside a conductor. If there is a conductor, potential inside the conductor is constant. How? That is the point. Potential is constant inside the conductor. Inside a conductor, at every point, potential is constant. Let us suppose this is a conductor. In the previous point, we have discussed that the electric field inside a conductor is 0. We all know that in the previous lectures that electric field is minus times dV upon dr. If electric field is 0, that means minus dV upon dr is 0. Good. dV upon dr equals to 0. That means dV upon dr is 0. Means differentiation of potential with respect to position is 0. That means we all know that differentiation of any quantity, if differentiation of any quantity is 0, that means the quantity is constant. Like if you differentiate 3 with respect to any variable, differentiation of constant is 0. That means if the differentiation is 0, that means the quantity is constant. Means differentiation of potential is 0. Differential of potential with respect to position is 0. That means potential is constant. Potential is constant inside the conductor. Next point, that is electric field on the surface of a conductor is directly proportional to the surface charge density, that is sigma. Electric field on the surface of a conductor is directly proportional to the sigma, means surface charge density. Let us suppose this is a conductor. This is a conductor. Take any Gaussian surface. Let us suppose this is cylindrical Gaussian surface. Half portion is inside the conductor and half portion is outside the conductor. This is the surface S. This is also S. This is also S. We can write phi is equals to Q by epsilon naught. Phi is equals to E dot S. According to the Gauss theorem, net flux is equals to net charge upon epsilon naught, and flux is equals to E dot S. We can write E S is equals to Q by epsilon naught. E is equals to Q by epsilon naught times S. Q by S. Q by S means charge upon surface area. Charge upon surface area is sigma, that is called surface charge density. Surface charge density or superficial charge density. That will be equals to E is equals to sigma upon epsilon naught. Epsilon naught is constant. We can say that E is directly proportional to sigma, means electric field on the surface of a conductor. Electric field on the surface of a conductor is directly proportional to the surface charge density. Last point, that is electric field is 0 in the cavity of a conductor. In the cavity of the conductor, net electric field is 0 in the cavity of the conductor. Let us suppose this is the conductor and this is the cavity of the conductor. This is the electric field is 0 in the cavity of the conductor if this is a conductor and this is the cavity of the conductor. Okay, let us suppose this is the Gaussian surface. This is the Gaussian surface. Okay, last point, electric field is 0 inside a cavity of a conductor. Let us suppose this is a conductor, this is a conductor, and this is the cavity of the conductor. This is the cavity of the conductor, and we need to prove the electric field is 0 inside the cavity of a conductor. If we also know that Q upon epsilon naught and phi is equals to E into S. We all know that there is, if we apply a Gauss theorem here, this is the Gaussian surface, and inside the Gaussian surface there is no charge. There is no charge. All the charges is outside the Gaussian surface. That means Q is 0. That means Q 0 upon epsilon naught is 0. Phi is equals to E dot S. E dot S is equals to 0. On comparing these two equations, E will be equals to 0. We can say that electric field is 0 inside the cavity of the conductor because there is no charge inside the cavity. And last point is electrostatic shielding. What is shielding? Shielding means कवर करना, यानी कि हम किसी चीज को अगर हम कवर करते हैं means covering of any system is called electrostatic shielding. Cover means इस तरह से इसको कवर करेंगे कि इसके अंदर कोई भी इलेक्ट्रिक फील्ड ना हो. तो अगर इलेक्ट्रिक फील्ड कहीं नहीं होती है, कुछ इस तरह से कवर करते हैं जिसमें इलेक्ट्रिक फील्ड नहीं होती है, तो उसको हम इलेक्ट्रोस्टैटिक शील्डिंग कहते हैं. और we all know that there is no electric field inside a conductor. If there is a system, let us suppose this is a system and we need to cover the system from the electric field, we must cover it or shield it from a conductor. If there exists an external field, no electric field will be inside the conductor because this is the conductor. That is safe. The system will be safe from the external electric field. That is electrostatic shielding. Okay, thank you.